Welcome back to Crunch Labs. I'm Mark Rober, and today we're going to be talking about the airball game and all the juicy engineering physics that come along with it. Now, if you just got the box and you don't know what it does, allow me to show you, because this one is a banger. So when you turn it on, this little impeller starts spinning. You feel some air coming out of here, right? It's like a mini hair dryer. And then magically, if you put the ball in here, it floats in this stream of air. But then what's really awesome is you could take this and you play a little game. We've got these little kind of like diving boards down here. Your goal is to flick them up like this and get it caught in the airstream. But you'll notice there's two sides. This is potentially a two-player game. You can either do it by yourself and see how many in a row you can get, or you play against someone else and they try and knock your ball out. But then you might notice it's hinged here. So you can actually turn this over to the side and magically it still keeps that ball afloat even at a really crazy angle like that. Isn't that awesome? And then maybe bring it back to center and turn it off and see if you can catch it. Boom. And the engineering principle effect here is called the Coanda effect. In fact, that is what our gear badge is for this month. It's one of those principles that's really interesting to demonstrate, but it's way cooler when you actually know what's going on, the physics behind it. So let's get right into it. As usual, we're going to start with our question of the day. And of course, you're not going to know the answer to it right away, but after a lot of demonstration with all the interesting objects on this table, you're going to be able to figure out. So let's see what it is. How can you make an apple explode without touching it with anything? Let's talk about it. And by the way, what I mean with that question is like, you can't use a hammer because that would be touching it with something. You can't punch it. Even using like explosives wouldn't be fair because that's a huge pressure wave that destroys it. Like, how can you literally not touch this apple at all and have it somehow explode? And maybe some of you already might know where I'm headed with this. And today's gonna be a little different because we're just gonna play a game called Will It Float? This used to be an old bit on the David Letterman talk show, except they would actually place items in a big tub of water and you'd have to guess, is it going to float or not in the water? In our case, we're going to take a bunch of these items, like, I don't know, this big ball, an orange, a Rubik's Cube, a screwdriver, a baby. We're going to put it either in the stream of an air compressor or maybe a blow dryer. Might even try a leaf blower. And the whole point of the game is, do we think it's going to float or not float? And I'm kind of excited to try a ton of these. I actually haven't tried a lot of these myself, so we're going to be learning and experimenting together. But before we play the game, let's just talk about the Coanda effect and what's actually going on here, because it's really interesting. Now, you might remember the very first lesson we ever did, we talked about frisbees flying through the air. We said a frisbee is basically a jetpack because as it travels through, it takes that air, it curves it down all around, which kind of propels it up, right? That was the Coanda effect. We briefly mentioned it there. But let's get into it a little bit more now here with this drawing we have on the board right here. So imagine this sphere here is this red ball, okay? And I've got this blow dryer here. So what is it about this that makes it stable, where the ball isn't falling off to one side or the other? These arrows represent the stream of air coming from the blow dryer and sort of curving around the ball. We know from the frisbee, we talked about how the air curves around, right? We had our little low budget wind tunnel with a little string, and we showed that just like water curves and sticks to a spoon, air will curve around and stick to a surface. Now, the way air streams work, this is one group of air molecules and they all love to hang out together. So they came out of the hairdryer together. They want to still hang out together, even if there's something in the way. So as these guys come around the ball, these air molecules speed up to catch up with their buddies, right? Because this is a bigger distance to travel. It's like if you're walking somewhere with their friend and they take a shortcut, but you take the long way, you kind of need to run when you're taking your long cut in order to catch up with them. Now, there's another principle that we won't get too much into right now called the Bernoulli principle, but basically for fluids, if it's going faster, it creates low pressure. So that means because these molecules are taking the long cut and they're trying to go faster to catch up with their buddies, all around this ball, it creates sort of a low pressure bubble. Because remember, this is a cross section, but basically this same cross section goes all around in 3 dimensions. So this ball, whatever's floating in that stream of the hairdryer, there's sort of a low pressure bubble all around it. That's why we can turn this to the side and it still stays in that stream, because you can imagine there's kind of just this bubble of low pressure. So the rest of the air at normal air pressure is pushing in on all sides. So if it starts to go out, it's like, the high pressure, it's gonna move it back into that like physical bubble in the air. It wants to stay inside that 3D bubble, which is why it can move it back and forth like this, and it just seems so stable. Alright, well that's the principle at play here. Now it's time to see it in action with the first ever Crunch Labs edition of Will It Float? Now again, the ping pong ball with the hairdryer is the classic. It's always going to work really well like this. You take it off to the side. That's the Coanda effect in action. Remember, there's this like 3-dimensional kind of sphere of low pressure air. It's like a bubble if the ball wants to stay inside, and that's just cool. But what if we were to try a tennis ball? Will it float? Place your guesses at home. I mean, a little actually. I mean, the answer is kind of yes. Wow, it's supposed to be no. Still, it's not as good as way up there. And what's happening there is the tennis ball just weighs a lot more than a ping pong ball, so the force of gravity has a bigger effect. It's winning that tug of war versus the force of the air pushing up. This is the same principle behind the fluidized bed, of like how we got the grains of sand to float. If you go back and watch that video, I also talk about this exact same principle. But I do have something a little more powerful than a hairdryer. An air pressure hose. So this is the exact same air pressure that powers our tennis ball cannon up there. We're stealing air pressure from the tennis ball cannon momentarily to use it for our Will It Float game. Tennis ball with this air pressure line at 100 PSI. Do we think it'll float? Oh, it floats. We got a floater! So if you guessed yes, you were right. Let's find some more objects. Okay, we now have a table full of amazing items, including a cucumber or zucchini. I never know. What is this? It's a cucumber. An orange. Or what is this? Just kidding. A carrot. It's a little, not very strong carrot. A hot dog, an actual orange, roll of tape, a toy boat, a Coke can, Rubik's Cube, screwdriver, baby, Nerf football, inflatable ball, bull bat, bull. Now start thinking which one of these things you think will float, which ones you think won't. I actually don't know the answer either, so we're just gonna experiment real time. Let's start with maybe the most obvious. An upcoming video of mine is all about wiffle ball and the physics behind it, and maybe if you have engineering skills, how to cheat a wiffle ball, because obviously I'm not gonna be very good compared to them. I feel like this is gonna be a float, but you place your own guesses. Here we go. Look at that. Did you get that? I got it right in the tape roll. Take that, Dude Perfect. So that if you guessed it will float, you win. How about orange? Now the difference is this is a lot heavier. Will it be able to overcome the force of gravity? There's only one way to find out. I think that floats-ish, you know? It's kind of like the tennis ball and the hairdryer. That's more like, will it levitate? In that case, yes, it levitated. All right. How about now this bowl? This is pretty lightweight, so I don't think it'll be too heavy. Question is, will that Coanda effect come into play? Definitely went in the air. Did not float. All right, time for the cucumber. What do you think? You know, it is rounded, so we are going to get the air kind of sticking to it. Is it round enough? A cucumber floats! How about this can? It is curved, it is light, just not sure if it's gonna like be too unstable. Place your guesses, here we go. Wow! Will it float? A can will not float. Too lightweight relative to how curvy it is. Rubik's Cube, what do you think there? Boo. So I think what's happening there is the sides are just too sharp and square, so you don't get all those air molecules rushing around to meet up with their buddies, and therefore you don't have that low pressure air bubble that forms to like keep it floating there. How about this screwdriver? That could be interesting. That worked really well. So the end of this is round enough that we're able to form that bubble. A bowl? It's round. Question is it stable enough? What's your guess? Here we go. Wow! That's cool. I was not expecting that to float. I thought it would be too unstable. Bowl works amazingly well. How about this roll of tape? It's kind of round. Whoa. This football could be interesting. It's kind of heavy. Place your guess for the football. Oh, it has one of these whistling things. All right, now let's see if we can get it to float. Here we go. Too heavy. See if I can get it in the foam pit. Ooh, almost took out the ceiling light. All right, green ball. Feel like this has got to be a floater. What do you guys think? Wow! It's like magic! No strings! Oh, there it goes. That was delightful. I was not expecting that to work as well. Bat, it doesn't have a nice rounded top, but it is pretty heavy. Place your guess at home. Here we go. It floats! And I'm a magician! Okay. Cup? What do we think? Certainly is light enough. Here we go. Okay, the cup is a bust. See a cup. Carrot? If the bat floated, feel like the carrot's gonna float. But what do you guys think? From now on, that's how I'm eating my carrots. It's a really gross carrot. I don't even want to eat this. This big bowl, we got the smaller blue bowl to float. Let's see if we can get this one to float. Not quite stable enough. Oh, this baby I'm real excited for. Can we get the baby head to float? The baby floats! Maybe I shouldn't throw the baby. Okay, that leaves just the boat and the hot dog. I think by this point, maybe you've kind of figured out the pattern. My guess is this is not gonna float. Wow! 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 Whatever floats your boat, clearly it's not air in this case. And this leaves us just with the hot dog. I wanted to save the hot dog for last because I have an idea here. Okay, that floats very well. It's time for a good old-fashioned weenie roast. We're gonna try a completely frictionless way to roast this hot dog. We have not practiced this. Oh, Josh got scared. All right. Well, that is a perfectly lukewarm hot dog. I am not going to take a bite out of this. Next time you have a camp out, all I'm saying is consider a 300-gallon, 100 PSI air compressor with a flamethrower. Just gonna put that on the table. Okay, so we did the hairdryer, we did the air compressor. I've got one more I'm just curious about. You might recognize this from the snowball machine gun video. Yeah! It's a good old-fashioned run-of-the-mill leaf blower. Here we go. concludes our Will and Flow segment. Thanks for playing along at home. Let's go back to the table. That was super exciting, but before we show how to put this thing together, we need to answer our question of the day, which is, how do you make an apple explode without touching it with anything? You might have a guess now, but if you take that apple and you put it in the airstream of an air compressor like this, it starts spinning and spinning faster and faster because there's no friction to slow it down, and at some point, the centripetal force pulling out on the apple is greater than the force of all the molecules holding the apple together, and it explodes. And if you were standing there watching it with your own eyes, check out how fast it actually happens. Alright, well now let's cover putting it together. As usual, you can watch me do it on video, or you have the booklet, so you can use either the video or the booklet or the combination. Just remember, I'm gonna blaze through this in about 4 minutes on the video, but it'll take you anywhere from about 4 minutes to an hour. First, find the DC motor and the blue adhesive foam. Then peel and stick the blue adhesive foam around the DC motor shaft. Make sure the 2 small holes in the adhesive foam line up with the corresponding holes in the motor body. Next, locate the wooden panel. Insert the DC motor shaft into the center hole. Make sure the holes in the DC motor line up with the holes in the wooden frame. Now find the blue screwdriver and 2 small metal bolts. Use the screwdriver to bolt the DC motor onto the wooden frame. Next, grab the red impeller and press the red impeller onto the DC motor shaft. Gather 6 short white bolts and 6 blue standoffs. Use the short white bolts to attach all 6 blue standoffs onto the 6 remaining holes in the wooden frame. Now grab the yellow foam spacer. Slide the yellow foam spacer over all 6 blue standoffs. Next, find 2 long white bolts, 2 white nuts, and 2 wooden square pieces. Slide the bolts into the holes in each of the square wood pieces and use the nuts to tighten them down. Insert the square wood pieces into the matching slits in the wood frame. Now locate the remaining wood panel and 6 more short white bolts. Use all 6 short white bolts to attach the wood panel to the front of the build. Find the blue nozzle and slide it into the square hole in the top of the build. Now grab the battery pack and the blue adhesive foam. Remove the safety tab from the battery pack, then peel and stick the adhesive foam from the side of the battery pack that has the on-off switch. Connect the wires of the battery pack to the wires on the DC motor. Make sure you connect the red wire to the red wire and the black wire to the black wire. Now it's time for a test. Turn your on-off switch to the on position. You should feel a gust of air start to come out of the top of the fan assembly. Try and place one of the styrofoam balls into the airstream and check out what happens. Now locate the large wood base, 2 wooden legs, and 2 clear O-rings. Slide the wooden legs into the slits in the wooden base, and then from the bottom, hook 2 white O-rings over the exposed tabs of the wooden legs to secure them in place. Grab 1 white bolt, 1 white nut, 2 wooden washers, and the red catapult arm. Place both wooden washers underneath the red catapult arm, then use the nut and bolt to attach the red catapult arm to the wooden base. Again, grab 1 white bolt, 1 white nut, 2 wooden washers, but this time the blue catapult arm. Just like the last step, place both wooden washers underneath the catapult arm, then use the nut and bolt to attach the blue catapult arm to the wooden base. Now push the wooden legs apart to make room for the fan assembly. Place the fan assembly in between the wooden legs so that the white bolts stick out of both holes in each wooden leg. Find the 2 white nuts and use them to tighten the fan assembly in place. Next, peel off the paper backing from the adhesive foam on the battery pack, then stick it to the underside of the wooden base so that the on-off switch is visible through the on-off rectangle from the top. Push the battery pack wires so that they pop into the keyhole cutout in the side of the wooden base. Now grab all 4 blue foam feet, then peel and stick the feet in each corner of the bottom of the wooden base. Lastly, place a ball on each of the catapults, and you're ready to go. Now it's time to give it a try. Flip your battery pack to the on position, and now use your finger to press down on one end of the catapult arms. Let your finger slide off and see if you can get the ball to land in the airstream above the fan. You could try this game by yourself and see how many you can get in a row, or you could try it with a friend and do like a King of the Hill mode. Just a little pro tip on how to aim. Depending on where you press the catapult arm, that will determine which way the ball launches. So if you press on the left side, the ball will go right. If you press on the right side, the ball will go left. Okay, now for the engineering hustle this month, I think the water in the sink trick is a pretty good one. You show them, a couple objects, and of course when you spray with water, it runs away from the water. You make a friendly wager that you can find an object that will actually be attracted to the water. No matter which way you spray, it will stay in the water stream. And then of course at that point, all you need to do is find some kind of spherical object that will be under the effect of the Coanda effect, because then it will create that low pressure like bubble, and it'll stay right under the water stream, and now you have just won some free dessert, or whatever the wager is of your choosing. It pays to know science. Alright, so for the prototype 2.0, of course this is where you see what you can do to take airball and just level it up. Maybe you see how many in a row you can get stuck in the stream. Maybe you take one of these balls and draw a little face on it and make a really lightweight kind of stick figure, maybe with the paper clip. And I bet you could get it floating in that airstream like a little human head floating around in the air. Maybe you work with an adult and you get your hair dryer and you see what items you can get trapped into the airflow of the hair dryer. Of course, using the Coanda effect, I know ping pong balls work really well. Basically, play your own version of Will It Float at your very own house. Oh, maybe another idea, and by the way, you can come up with way cooler ones than this, is get a ball floating in the airstream here and see if you can use the disc from your disc launcher and do like a sharpshooter thing, and then knock it out of the stream. Just don't forget to use those same sound effects. Okay, well, good job today. As always, remember, engineering is an iterative process. We call it Crunch Labs because we're supposed to crunch and break things. You can see sort of the design evolution, and this is like a third of all the prototypes we did to finally get to this beautiful version. You know, this was the first really rudimentary sort of impeller. We just kind of a very quick and dirty mod. You know, we started with this kind of form factor. At one point, we were using Velcro to have different angles. We had these different shaped nozzles for the top we were testing to see which would give you the best airflow to keep things up in the air. The point is, as an engineer, you don't know what you don't know, and the only way to know is just to try and to build and to test and to fail and to tweak and to iterate and to make it better. Either way, no matter what you do, make sure to show it off, show your friends and family. You can work with your parent and post it online, tag us at Crunch Labs. I see all of those, and I make react videos to them, and I absolutely love seeing the brilliant ideas all of you come up with. Alright, well that's it. Congratulations. You've earned your gear badge for the Coanda effect, so make sure you add that to your diploma and you go off and put together your airball. And I'll catch you next month right here at Crunch Labs. Oh, and if you're watching this and you haven't yet ordered your BuildBox subscription from Crunch Labs, then what the heck are you waiting for? Visit crunchlabs.com with the parents, and once you're there, you can learn more about how it all works. Thanks for watching.